To touch on some of the big ideas for using models in the science classroom, we have this slide here that has about 5. There are some other things, but these are some of the broader, bigger things to consider while you're working on models in your classroom. First off, models are about the phenomena, which is an event that needs to be explained. When we make a model of a cell, we're not doing modeling. However, if we're making a model of a cell and using it to explain osmosis, then we've reached modeling. This is the same is true about volcanoes. Now, I pick on these two because they're the most often used. A baking soda volcano really doesn't necessarily explain how a volcano works. The specifics of our models, time, place, certain conditions, is what can make them interesting to students. There always should be a visual piece to the model. The model should include both observable and unobservable pieces. So things that I usually tell students is questions I use with students is what might be happening here that is going on that's causing this situation that we can't physically see. So things such as like dissolved oxygen, atoms, big items such as a solar eclipse, things that happen over long periods of time like evolution, inaccessible items such as layers of the earth, conceptual like sound waves, and most importantly, probably here at the end, is our models need to be revisable. And that gets across a point to the students that when they see that science has changed something, it's not that they were wrong, it's the fact that we have found more information and we're now incorporating that information into our current model in order to improve it. So what to use? We have a picture here of some Oreos in the Oreo moon phases. Over here we have something that kind of hit Pinterest not too long ago, and then we have a picture of somebody using a ball and stick model and a light source in order to do moon phases. So we definitely have 3 distinct models. Now, while each one of these are considered a model, the question should be for teachers when deciding what to use in the classroom is, what will students learn from this? If we look at our moon phase model using the Oreos, I'll give you a couple of seconds here just to consider, what do you think students would learn from engaging or building or making this model? So with our Oreo model, hopefully you were thinking about the fact that the students possibly could see what each moon phase looks like, but it's really hard to get anything else from that model except for the moon phases. Next on our list is our Pinterest model, and let's take a few minutes to consider what students can learn from this model. Now notice that the cups, there are 2 cups if you haven't seen this one, and notice the arrow means turn, so that tells you which direction to turn the outside cup, and they will go through and see the different phases as we go turn the cup. Once again, hopefully you noticed that at best that this model will help students learn the phases of the moon and what the phases look like. Our final one down here with our ball and stick model and a light source, this model allows students to do a bit more. I'll give you some time to consider what this one can do. This one kind of gets to the point of how the moon phases occur. Because the moon phases, we have a light source which would stand for our sun, we have a ball which stands for our moon, and we can move that ball around our light in order to see what's going on with that. Now, do each of these models each have detractors or things that aren't quite correct about them? You bet. There's no such thing as a perfect model. However, in terms of getting to what NGSS is wanting students to do with models on a middle school level, our final example here with the ball and stick for the moon phases is finally taking steps in that direction. Other things we do okay, so here, while I would tell you I would never grade a student's model because I'm a firm believer models are thinking tools for my students, meaning I have them build initial models, and as we get more information, we go back and we revise our models, and we get more information, and we go back and usually are able to polish our models at that point. So these are thinking tools for my kids. So I don't spend time with grading student work. But if we look at this rubric for student scientific models, which by the way was produced by the Research and Practice Collaboratory, notice that on this first page we have the base elements of all models. So the first one that it explains the phenomena. And if we think back to like our Oreo cookies, model does not explain the phenomena of investigation. So does our Oreo cookies explain how the moon phases happen? Well, I would have to be in the not yet. Fits evidence. Does a model fit with evidence collected? Well, if I were collecting evidence about the moon phases and how they change and the patterns during the course of the month and where they're located in the sky, we can say that maybe possibly the model incorporates some of the evidence collected through the investigations. Builds on science ideas. Does the model include some of the disciplinary science concepts and cross-cutting concepts needed? It doesn't quite get to meet expectations. Once again, it's probably in the approaching or maybe even down into the not yet, but there are some disciplinary core ideas available in that model, but not a whole lot going on there. Clarity of communication. Model is not clearly described. Model is somewhat clearly described. So, or does a model clearly describe it in a way that allows others to understand how and why the phenomena happens? Well, once again, we're down in that approaches expectations. Generality, can my model be used to explain related phenomena? Probably not, so that would be in the not yet. Consider other ideas. Did I consider how other people might explain this phenomena? Model doesn't consider the ideas of others. And personal connection, did I show that I have a local or personal connection to the model I created? And that would probably be no, once again. Now, the second page of the rubric, this is for more specific type situations. So notice it's optional scoring elements based on instructional focus. So these are things where do I look for whether or not students revise their model? Did the students evaluate the limitations of their model? Did they use the model to predict the phenomena? And can they use my model to generate data to test ideas? So not every one of these is going to be important each time to students, but at different times there's going to be different emphasis depending on what I decide to do with my model.